everyone, hope you're doing fine. In this video we're going to see 10 more MCQs, so let's get started.
And before we start, I would really appreciate it if you could smash that like button, drop me a comment and share this free program with anyone who might need it.
So the first question is the unit of elastic modulus is same as that of what? So what is my unit of elastic modulus? It's Newton per meter square or millimeter square, something like that. So when I look at the stress, it is Newton per meter square, and coming to shear modulus is shear stress divided by shear strain. This has no unit. For shear stress it's Newton per meter square. So for pressure it is Newton per meter square. So all the things have the same unit. So my answer is this. If we look at the other things also, it's strain but force has unit. Again, stress is different and force is Newton, and again strain has no unit whereas stress has unit. So the answer is A. Going to the next question. For linear, elastic, isotropic and homogeneous material, the number of elastic constants required to relate stress and strain is what? So it is isotropic, therefore it is 2. So if it is orthotropic, it is 9. If it is aniso, it is 21. So we have seen this already in the previous video. Next question, if the cross section of the member is subjected to uniform shear stress of intensity Q and the strain energy stored per unit volume is equal to what? And G is my modulus of rigidity. That is my shear modulus. So what is my strain energy? So we know the formula for strain energy. It is equal to, in the previous videos we have seen that it is equal to sigma square divided by 2E into V. So they have asked for per unit volume. So I'm going to divide it by V. It gets cancelled. Sigma square divided by 2E. So they have given shear stress in terms of stress. So it is denoted by Q. So this becomes Q square divided by 2. Since it is shear stress, this becomes shear modulus, which is G. So my answer is option C. Now to the next question. In case of engineering material under unidirectional stress in x-axis, the Poisson's ratio is what? So what is Poisson's ratio? It is lateral strain divided by longitudinal strain. So both the things are strain by strain. So when we look at the formula, it has stress, stress, stress. So this only has strain. So this is my answer. Next question. 100 mm long and 50 mm diameter steel rod fits snugly between two rigid walls 100 mm apart at room temperature. So this means these are my two walls. It is 100 mm apart, and a rod of 50 mm dia. So the dia is 50 and the length is 100 mm. So we can see that it is about the expansion of steel. So since the movement is restricted, stress will be developed. Had been something like this, just the bar free to move, then there will be zero stresses. But since it is restricted on both the sides, stresses will be developed. So they have given the value for elastic modulus, the Young's modulus and the alpha value, and the temperature difference is 100 degrees centigrade. So they have asked for stress developed. Know that the change in length due to the temperature rise, which is delta L, is equal to L alpha into delta T. We know this stress by strain is equal to modulus of elasticity. So from this, if we need stress, we can tell that stress is equal to strain into modulus of elasticity. So here, what is strain again? Strain is equal to delta L by L. E is equal to delta L by L. Then delta L is equal to L alpha T. So L alpha T divided by L. So LL gets cancelled. I'm sorry, alpha here. So therefore, strain is equal to alpha into delta T. That is change in temperature. So this is my alpha. I know the stress formula is strain into modulus of elasticity. So my stress is equal to E into alpha into delta T. So if I substitute the value for E, it is 2 into 10 power 5 to 40 Newton per mm square. So my answer is option C. Going to the next question. So I want you guys to remember this formula. During tensile test of a specimen using UTM, that is Universal Testing Machine, the parameters actually measured include what? What will we do in a UTM machine? Say I am performing tension test for a mild steel rod. So mild steel bar will be plain like this, whereas HYST bars will have ribs like this. So say I am doing it for a mild steel bar. So what I will do, this is my UTM machine and I will place the rod here, and there will be locks here which will hold the rod in place, and from here the load will be applied in the opposite direction, and the applied load can be monitored in a machine somewhere here. We'll have an arrow which will tell us the value of the load that is being applied. So with this load we also need to measure the strain value. So from this we'll get stress. We have to measure strain also because we have to draw the stress strain curve now. So in order to measure that, we will insert something called a tensometer. What will this tensometer do is it will measure the deflection that is happening in this rod, and in turn with the help of that we will be able to find the strain also. So we can see that after certain calculations only we will be able to arrive at the stress and strain of the material. But in reality we will be measuring load here and deflection here. So these are the parameters that are actually measured in a UTM machine. So if you look at the options, load and deflection. Next question, if the value of Poisson's ratio is 0, then what does that mean? So what is Poisson's ratio? It is equal to negative value of lateral strain by longitudinal strain. This means if Poisson's ratio is 0, then it means that lateral strain is equal to 0. Longitudinal, it may or may not be equal to 0. So what does it mean when the lateral strain is 0? So if I apply a load here, the lateral strain in the material, that is, there is no expansion or change in dimension of the material laterally. So this means that the material is rigid. The answer is the material is rigid. Next question, E has been given, alpha has been given, and it is fixed at both ends. So it is fixed, therefore stress is present. It is uniformly heated such that the increase in temperature delta T is also given. The stress developed in the rod is what? So we have already seen stress is equal to E into alpha into delta T. So we know the E value, we know alpha value, we know delta T value. So I'm sure you guys will be able to find the answer for this one. I want you to comment the answers below for this question. Next question, they have asked for change in length. So general formula for change in length is PL by AE. But the problem here is the rod is tapering. A circular rod is tapering from one diameter to another. So from D1 to D2. So we have to find what is the change in length. So since it is a circular diameter, I'm just going to assume that area is equal to pi d square by 4, just like any circle. So if I do it, it is PL by pi d square into E and 4, and this 4 can be taken upward. So it is P 4PL divided by pi d square into E. So I'm going to check my answers which has 4PL in the numerator. Only D has the answer, therefore D is my answer. The approach can be used if you don't know the answer for it. If you know the answer, then it is well and good, you can go for it. If you don't know, you can do like this also. Some of the tips that you can follow in case you don't know the answer is to check for the unit and to check for the formulas like this. If A is given and if it is a circular section, then definitely pi will be involved. So if you know that pi will be involved, then you can easily eliminate these two things because pi is not given in these two things. Using those logics, you can be able to arrive at the answer. But in case you don't know them, it is always better to know the answer. But in case you don't know them, you can use these approaches also. Next question. If Poisson's ratio for a material is 0.5, then the elastic modulus of the material is what? So mu is given, E is asked. So it has been asked in terms of shear modulus. So we know the relation between these three things. E is equal to 2G into 1 plus mu. So this relation, it has been asked in so many questions. So I'm stressing it again. Those four relations which we saw in the previous video, right? Which you can find it here coming now. If you watch that video, you can see all the four relations that are very important in any interview that you are going or any exam you are going. So coming to the question again, A is equal to 2G into 1 plus mu. So mu is 0.5 they have given. My E is equal to 3G. So my Young's modulus is 3 times the shear modulus. The answer is option A. So with this we come to the end of the video. I hope you found this useful, and if you did, please do give it a like and subscribe to the channel. Thank you so much for watching, guys. I'll see you in the next video, and if you're preparing for interviews, all the best for your interviews. Thank you. You can do it. Bye bye. Stay safe.